Thank you very much for having me here. I don't have any slides. I thought I'll just have a good conversation about the topic that I've been given. It's really good to see so many sponsors and so many technology players in one area spending a couple of days talking about what's going on in the automotive industry. Where are we headed? What are the challenges? How do we tackle them individually and together? So it's a really great gathering, and very happy to be here. So I'm going to talk a little bit about the connectivity revolution and autonomous driving and how safety is at the top of the mind of so many people. And I'm going to talk more specifically for commercial vehicle industry because that's what I represent here. So I'm part of Daimler Trucks. I head the engineering and innovation center here in India, which is dedicated for Daimler Trucks. I'm sure some, if not all of you, know about Daimler Trucks. We are the largest manufacturers of commercial vehicles, which is bus and trucks across the globe. We have businesses and products across the world. In North America, we have more than 40% market share in heavy trucking industry, 40 tons and above, and we're also very large in Central and Western Europe. So if you look at what's going on in the auto industry, specifically in the commercial vehicle industry, is there are two large trends, what we call as mega trends. One is we want to get out of fossil fuels, get to what we call as zero emission, where we stop using diesel and which pollutes this world, and we take full responsibility for what we do in terms of adding carbon and NOx emissions to the environment. So we're moving to more, I would say, zero emission technologies like battery powered trucks and hydrogen powered trucks. That's one mega trend. The second is to really use software to make our trucks more intelligent, safer, provide better comfort, and also provide value to our fleets. There is one big difference between passenger car and commercial vehicles when it comes to automotive industry. Passenger cars are, it's a B2C business, and people buy cars for a variety of reasons. And it's also an emotional product where people, buy the cars and they are really, really attached to that. People don't buy our trucks because they're pretty. They are pretty. They're very good looking. But they buy trucks to run their business. So the way we sell our trucks is very simple: total cost of ownership, whether it is fuel economy, whether it is generating value out of connected trucks, whether it is keeping trucks on the road as far as possible and not having unplanned downtimes and so on and so on. So these are very, very business metrics that we are measured against. So even though the underlying technology is the same, how we connect the vehicle to the cloud, how we stream data real time, and how we have a chatty interface with the cloud and all of that, but the way it is used and the value it provides in a commercial vehicle industry is very, very different. So if you look at what connectivity does, connectivity basically provides value to OEMs, which is us. It gives very valuable information back to us from the truck on a real-time basis, which we use in engineering, which we use to predict when the parts might fail, and a variety of other use cases. And it provides real-time feedback to the driver to make the journey safer, faster, better. But I think the highest amount of value it provides is to the fleets, right? And fleet managers who can schedule their trucks better, who know exactly where the truck is, and how to make most out of those trucks. So these are the three values it provides, and without these business values, I don't think anybody would pay for connected solutions. It's not fancy. It's very basic, and it provides business value. And a few things that make this possible. One is the truck needs to have the underlying technology, and Mr. Arvind spoke about how the compute in the truck is evolving. We still have more than 80 mini computers, which we call as ECUs in our trucks today. But our next generation technology will collapse this into 2 or 3 high-performing computers, centralized compute. These computers have gotten smaller, more powerful, very reliable, and most importantly, they are getting more and more economical. Because every dollar, every euro we add to the cost of the truck, there is huge amount of scrutiny because this adds to the overall cost. So as the compute follows the Murphy's Law, I think we are reaching the limits of that. The computers are getting smaller, smarter, more reliable. That's one revolution that has helped the connectivity go through the roof. Second and most important is the telecom infrastructure across the globe. We've gone from 3G to 4G to 5G now. The important thing for trucks is they go in all sorts of places around the world. They go to places where the passenger vehicles would never go, and there getting a consistent high-speed connectivity has been a huge challenge. But we are seeing that the drop in connectivity as the trucks go from coast to coast in US or across the length and breadth of India or in Europe, I think the places where we lose connectivity are becoming smaller and smaller, which means you have a consistent high bandwidth, high speed connectivity to the cloud. That's the second technology. And of course, the intelligence in the software and the predictive algorithms have really come of age in the last decade or so. So the question is, how do you take advantage of these 3 technology revolutions to provide business value? Like I said, in commercial vehicles, it's all about providing business value. It's not about being fancy, or it's not about being emotional about the products. So that's what I think every auto OEM is trying to do. It's a very, very geographically different in different areas of the world, how connectivity is used. I think India has really made huge progress. I think we're going to skip a generation here, where we go from basic connected solutions to very, very advanced connected solutions. Our brand, Bharat-Benz, which is in Chennai, we work with them, and they have rolled out their connectivity solutions earlier this year, and the response has been really, really good from our fleet customers. So that's what is going on. And some of the use cases, if I were to speak, is the fleet managers know exactly where their trucks are. They know how they're doing on their trips. Are they getting there on time? Is there a delay? Do they need to reroute? And that kind of control gives them huge amount of business value. But some of the more advanced things that we're developing on connectivity is how do you give real-time feedback to the driver? For example, if the driver is driving into a traffic jam on a highway, for example, how do you brake and reduce the speed of the truck automatically so that he doesn't have to panic brake, and when he drives into the tail of the traffic jam, the truck is already slowing down, and this has relevance from safety standpoint and also from fuel economy standpoint. Even 0.5% fuel economy means huge amount of money for the fleets. So I think what we can do with connected technology is only limited by our imagination, right? And how we provide these real-time feedbacks. And especially on electric trucks, where we are still learning how to calculate the range. The range prediction is not as simple as what we can do for diesel trucks. It's pretty simple, straightforward physics-based model that we use. But when it comes to batteries, it's very, very unpredictable. It depends on the cell chemistry, it depends on how you package, it depends on how you're using the energy. So we are building predictive models, and this needs real-time data from trucks to be, transferred to the cloud. So connectivity is going to be the next revolution in commercial vehicles for OEMs to create new revenue streams from subscription models, for drivers to get real-time feedback, and for products to really predict when the product will fail, when the component will fail, and for fleets to really understand how their fleet is doing. So this is a very competitive field, and I think we are just scratching the surface. Autonomous technology, I think this is something which we've been trying to get over the finish line for more than 2 decades now. Cars, self-driving cars, they are there, but they're not there at the same time. They're there in a limited capacity. Still a lot of safety issues, still a lot of regulatory concerns. The technology is not perfect, but it is making progress. What does it mean for commercial vehicles? I think self-driving trucks are going to completely transform the commercial vehicle industry if and when they arrive. So there are 2 ways we look at it. One is what we call as hub-to-hub, which is the hubs that are there, logistics hubs that are there very close to the highways. So a truck drives from one hub to another hub by itself. So mostly it is driving on the highway, which is an easier problem to solve from a computer science standpoint, because you have lane markers, you have very predictable conditions, not too many traffic signs, stop signs, or weird traffic conditions like roundabouts and so on. So it's a easier problem to solve. That's one way that we look at it. The other is door to door, which is the truck drives itself on the highway, of course, but also inside the city. This is order of magnitude more complex, and we run into the same issues that the passenger cars have been running into for years. I think hub-to-hub is a more feasible and provides huge business case, because the biggest challenge we have, at least in the West, is the availability of drivers and the rules around how much a driver can drive. There are number of hours you have to drive, and then the truck is parked for lack of drivers. So if the truck can drive itself, it can be on the road 24/7. And that's just going to change the whole thing. Are we there? No. And the most frequent question that is asked is, when will we get there? There is no right answer to that. It's very, very difficult to answer. The issues are very complex, whether it is perception algorithms, whether it is the computer science problems we're trying to solve, regulatory issues that we're grappling with, safety issues, corner cases, all of that. But I think it's a technology that we as Daimler Truck bet on. We have a group company called Torque, which is trying to put autonomous trucks on the road, at least in the US, soon. So it will change the commercial vehicle industry in ways that we haven't seen. And it will make it much more efficient. But there are technology challenges, regulatory challenges, process challenges, all sorts of challenges. But I think there's a fair bit of progress that is being made. But what we cannot and should not forget is that we also have active safety systems, what we call as ADAS, active driver assistance systems, where the software on the truck makes the truck safe actively, like it will brake, emergency braking. Or if the driver is not able to see a bicyclist or a pedestrian, but the cameras and the sensors can see them. So I think these technologies are extremely mature. They are in the trucks already, and they're regulated. And we've seen in the recent times the Indian government's rolling out regulations, and they've even advanced the regulations by a year, which is a bit of a shock for the OEMs, and we are We are running as fast as we can to get the technology in our trucks, in Bharat-Benz trucks. But I think this is in the right direction, because these are huge machines, and they can be very, very unsafe for the environment. So I think that technology has been mastered over the last two to 3 decades. But the autonomous trucks, the jury is still out. Huge amount of investment going in, and whoever gets there first is going to have a huge competitive advantage, no doubt about that. So that's where we are, I think, in the commercial vehicle industry. A little bit of a business perspective, not a technical perspective, but I think that's where the investments are, and that's where the engineering talent is being deployed. One, to move from fossil fuels to zero emission. It's a very complex problem. You need charging, you need, to produce green energy and green hydrogen and transport, very complex problem. And then the other is, how do we use software to make the trucks better, faster, safer, and more comfortable? I hope it gave you some perspective. Thanks for having me here, and have a great conference for next 2 days. Thank you.